The Colorado State logo and Colorado Department of Education logo appear center screen. The video transitions to on-screen text that reads, "Pose purposeful questions" with the logos now at the bottom center of the screen. The on-screen text transitions to new text that reads, "Effective teaching of mathematics uses purposeful questions to assess and advance students' reasoning and sense-making about important mathematical ideas and relationships, principles to actions, and CTM." Two students appear on screen sitting at a table facing forward.
Okay, pause where we're at, real fast, eyes up.
The camera changes to a teacher, Mrs. Glickman, standing in front of a middle school class with a whiteboard behind her. A graphic text appears in the upper right corner that reads, "Mrs. Glickman's 7th grade class, Colorado Springs, Colorado." The text graphic slides away.
Okay, I liked what I was hearing from the teams. Mike, I'm gonna pull your guys' team. What were we talking about over there? What did I challenge you guys on?
You wanted us to see if we can make more equivalent, more for expressions.
Ah, good catch there.
Mrs. Glickman turns and writes 2 squared times 2 to the power of 3 equals 2 to the power of 5 on the whiteboard. A graphic showing the equation appears on screen.
So on number 3, you had 2 squared times 2 to the power of 3. And then we realized it was the same as 2 to the power of 5. I challenged them if they're equivalent. That's our key word. Okay, we're looking at equivalent expressions today. What's another way you could write it? What's a different way that your teams can write it?
A new graphic appears on screen under the original one that reads, 2 squared plus 2 to the power of 3 equals question mark?
What's a different way, William?
2 to the power of 2 less.
Some students are shown disagreeing.
No, because you would...
The camera changes back to the teacher. A text graphic appears on screen that reads, "What information is the teacher trying to gather with these questions?" The text graphic slides away.
Okay, we're challenging no. Why?
Mrs. Glickman points to a student to answer. The camera changes to the student speaking.
Somebody.
Because if it's like that, you would, instead of like multiplying where you can keep the not the exponent number the same, you would be adding the 2's together. So it'd be 4 to the 7th power.
The math equation graphics appear back on screen.
Or because wouldn't you would add the 2's together, so that would be 4, and then, oh, is that a 3?
The camera changes back to the teacher and the math equation graphics appear back on screen.
Yeah.
Oh, I see a 5. Oh,
Sorry.
So then it would be 4 to the 5th power.
Would it?
No.
Oh.
Okay, so just fine.
Mrs. Glickman points to another student to answer. The camera changes to the student speaking and zooms in.
Audrey, go.
Because order of operations, you would do exponents before you add.
The camera changes back to the teacher writing the words, "order of operations" on the board. The math equation graphic appears back on screen, with 2 squared plus 2 to the power of 3 crossed out. And the words "order of operations" appear underneath the equations.
Good. Order of operations. This is part of what today's going to be, which is why I want to kind of open the conversation here. I'm going to leave it there for you because that is the piece for today as we're going through our goals.
The video transitions to on-screen text that reads, "What questions in this lesson do you think the teacher prepared in advance and why?" 3 students and a teacher, Mrs. Krause, appear on camera facing a whiteboard on the wall. The students are writing a math equation on the whiteboard. A graphic text appears in the upper right corner that reads, "Mrs. Krause's 6th grade class, Broomfield, Colorado." The text graphic slides away.
So if there's 2, -1, then that means there's -1 too, right?
Can you start also to develop a pattern? Can you start before 2 to the 1st? Like maybe start further up and see if any patterns develop?
So 2 to the 2 is 4. 2 to 3, 8. So it's divide by 2 each. Divide by 2 each time. That's a pattern.
Divide by 2.
So if we it's divide by 2 each time. So does that mean we divide this one?
This would be 1.
A text graphic appears on screen that reads, "How does the teacher respond when students answer incorrectly?" The text graphic slides away.
Okay. Well, what are you skipping? Which
0.
Yeah, you're skipping 0, so you have to get that in.
So if we have 0, then it's
And then what did you
there's
say
0
about the
twos.
pattern?
So that 2 to
It's
the power of
dividing
0
by
is just
2
nothing.
each
Okay,
time.
so write that
But
down
this
so you
divide
can
by 2
visually
is
see
1.
it.
So then
Yeah.
this with 0 divided by 2.
Well, but
Not with 0.
2 divided by 2. 2 divided by 2 is not 0.
Yes,
Okay,
it's 1.
so 2 divided by 2 is not 0. So then, if the pattern is continuing, what do you think 2 to the 0 is?
Oh, it's
then
just
it must
not
be
0.
1, right?
2.
Yeah, it has to be.
Is there
pattern.
another way you can prove it with our powers, like a power of power, property, and our quotient of power of
Okay.
property? Try
So
to
if we
think of
have
that.
2 to the 10th power
Okay.
divided by 2 to the
The camera changes to see what the students are writing.
10th power.
Okay.
We have, well, actually, let me do just 3. 2 to the 3rd power and 2 to the 3rd power. We have 1, 2, 3. We have 1, 2, 3 twos, right?
Yep.
Divided by 1,
It's
2,
0. It's to the
3
power of
twos.
0.
So each of these knock each other out.
The camera changes to include the whole group.
So what is 2 divided by 2?
1.
And what is 2 divided by 2?
1.
And 2 divided by 2?
1. And
So
then
your answer is
1. Okay, so this equals 1.
The video transitions to on-screen text that reads, which questions most effectively elicited student thinking? Which questions could be improved and why? The video transitions to the Colorado State logo and the Colorado Department of Education logo.